Good morning, everyone, and welcome to today's last session. Can everyone see the whiteboard?
Yes, sir.
Okay, great. So today we're going to review the contents of modules 3, 4, and 5, which will be on the second test. And I'll begin, as usual, by highlighting the latest class announcements. So in the announcement section at the very top, you can find my personal availability link. If you desire to set up an appointment, either for the evening tutorial sessions or the regular office hours, you will need to click on this link and it will prompt you to log into Navigate. Once you log into Navigate, you will have two options. If you desire to set up an appointment during office hours, you select faculty under services. But if you desire to set up an appointment for the evening tutorial sessions, you select the option of Reach Tutorials. So take note, if you select Reach Tutorials, you only see the availability for the evening times. If you select faculty, you would see the availability for the regular office hours as listed in the syllabus. And then secondly, you must have received this. This was sent out on September 16th about grades. So there are two grades in Blackboard. There's the raw grade, which is your real grade in the course. And then there's the current grade, which is a projection of where you may end up if the lowest activities are dropped as specified in the syllabus. So the raw grade shows your actual level in the course or your actual proficiency in the course, including all the things you've missed or the ones you didn't do well on. And then the current grade is where you will likely end up if the lowest grades are dropped. And the word of caution here is that the current grade will change continuously as more and more activities are graded. So some of you did very poor on test number 1, but your current grade shows like a B or something higher. That is because the Blackboard calculation as shown below in this screenshot drops the lowest test score, the lowest discussion, the lowest quiz. So if you did very poor on test number 1, then Blackboard likely dropped that score and didn't count it in calculating your current grade. That's why your current grade may appear to be artificially high. So don't be lured into a false sense of security that you're doing well in the course if you know that you didn't do well on test number 1. So pay attention to these two grade columns. The two will change continuously as more and more activities are completed. And I wanted to say, in a transparent manner, how you're doing in the course so that there'll be no last, minute surprises of students saying, I didn't know my actual grade in the course. So based on this, you can see how your actual grade is calculated, and note that the drop scores are not deleted from Blackboard. So when you log in, you still see your lowest scores in your gradebook, but the Blackboard calculation in the background excludes the lowest activities as specified in these settings. Finally, you've heard the word at-risk students a lot from the beginning. A student is defined to be at risk if they currently have a failing raw grade. That means they're not doing well. They didn't do well on test number 1, and they've missed like 2 or more graded activities. So if you meet this definition, it's mandatory for you to attend at least one evening tutoring session a week until you move your grade into the green. Remember, these tutoring sessions are your last opportunity to get back, on the path to succeed. And I keep stressing this because at past the midterm, it becomes increasingly difficult to recover if you're failing. But before the midterm, there are enough course activities to put you back on track if you start doing the right things. Because some students, simply perform poorly on the test because of the wrong study approach or because of neglecting certain things that they need to do before the test. So attending these sessions or setting up a conference with your instructor during office hours will help us identify or diagnose these issues early and put you back on the path to succeed. So take advantage of this. Don't wait until after the midterms, after you failed, let's say test number 1, test number 2, and we've done more than half of the discussions, more than half of the quizzes, and you just have like maybe 3 or 4 activities left, and it's virtually impossible for you to get back into a passing situation. If you wait till then there's really nothing that I'll be able to do about your situation. So take advantage of that. And one last reminder, test number 2, September 28th. You should have set up your appointment by now in Proctor U. If you haven't yet done so, there's still time before the premium fees kick in. So take advantage of that. If you desire to, there'll be an opportunity to take the test on campus, but those who want to take the test on campus must come to campus on the test day at 2 p.m. because there's only one, face-to-face class meeting for this class, and that is for section 3. It's set up every Tuesday, Thursday at 2 p.m. in the Anderson lecture room. So if you desire, if you're, let's say, located in Tuskegee and you want to take the test on your computer on campus in person, you will need to send me an email indicating that you want to take advantage of, on-campus proctoring, and I will confirm the space for you to do so. But the constraint is you don't have flexibility. You cannot choose the time during which you want to take the test. You have to show up on the test day at 2 p.m. in Anderson lecture room. Those taking online have the flexibility to pick a time within the testing window, that works for them, and they're free to take the test from any location that meets, the proctoring standards. So if you desire to take advantage of on-campus proctoring, send me an email. I'll put the location here. So on-campus proctoring option. Test number 2. So Tuesday, September 28th. You cannot just show up on campus. You must send an email and get approval. And also remember, for you to get on campus, you must have clearance to be on campus, which means you must have submitted, your negative COVID-19 test. If you haven't done so, if you're not cleared to be on campus, you cannot just show up, for on-campus proctoring. So send an email So today is the 21st. So Friday should be the 23rd. So send an email to me on or before this Friday. The subject line should read on-campus proctoring request. And once confirmed, you will still need to show up with a functional computer that is capable of connecting wirelessly to the internet. The only difference is you'll be proctored in person. That means I'll unlock the exam for you at the testing venue, but you still take it online, but you won't have to, go through Proctor U. There is no paper version of any of the exams due to the COVID, constraints. So that's that for test number 2. Are there any questions or comments at this time before we get into the second part of this session? At the chats. Okay, so when somebody says, was attendance taken? No, attendance hasn't yet been taken. Attendance will be taken at the end of the class. The midterm, so the second test counts as your midterm exam. And your midterm grade will be determined by your current grade after the second test. The midterm grade doesn't really go into your transcript. It's just a metric to see how you're doing in the course and to determine if there is need for extra help, for you to seek tutoring and so on, because the school is committed to help students succeed. So the school uses the midterm grade to determine who is doing well and who is not. Having a passing midterm grade is no guarantee that you will pass the course if you relax after that. I've seen students with a passing midterm grade fail the class. I've also seen students with a failing midterm grade pass the class. So take note of that. Okay, so if there are no questions, we're going to go to module 5 and begin with some practice problems. So pull up on your device, pull up the textbook and go to chapter 5, end of chapter problems. I'm going to pull up a version of the book here and share it with us, but I want everyone to be following the same problems in the book so that when you study on your own, you know where to find the problems. So if you go to the book in chapter 5, so this is the summary of chapter 5, rotational angle and angular velocity, angular acceleration, tangential acceleration, centripetal acceleration, then the kinematics of rotational motion. You have this similar equations like the one for 1D and 2D kinematics. And then you have Newton's universal law of gravitation, and then satellites and Kepler's laws. So all of these are discussed in the recorded lecture, which you should have reviewed before today's class. And we're going to scroll down to the problems and exercises section of the textbook. So I'm showing you where to locate, or where to find the practice problems in the textbook. So let's start with problem number 2. Somebody read problem number 2 for us.
I will. Number 2 says microwave ovens rotate at a rate of about 6 minutes. What is this in revolutions per second? What is the angle velocity in radians per second?
Okay. So any suggestions? Do you know how to proceed from here?
Would you not just convert the minutes to seconds first? So do there's 60 seconds in a minute, and so you would just do that to get the revolutions per second.
Okay. So it says, what's the revolutions per second? What is the angular velocity in radians per second? So Courtney suggests that we convert the minutes to seconds. So number 2, this is chapter 5. So select it. Okay, so the angular velocity is 6 revs per minute. Angular velocity is denoted by omega, it's like a W, so 6 rev per minute. And rev per minute means, rev here stands for revolution. So Courtney suggests that we do 1 minute equals 60 seconds, right?
Right.
So that means the angular velocity would be 6 rev divided by 60 seconds, which is what is that?
0.1.
0.1 rev per second. Okay. Now, how do we go from rev per minute to radians per second?
Hang on, I'd have to find the formula. It's not on this thing. Hang on, let me look at my notes.
Okay. So, and this is to the whole class, okay? This should be an interactive session with everyone, contributing or giving feedback or asking follow-up questions. But this is not a lecture. This is like a practice session. Keith,
I'm trying to find the book where you are.
yeah, you should have access to this. So one of the first activities in this course was to download the book. So you should actually have this on your computer. If you haven't done so, you can access the link to download the book from the syllabus and course material section of the course in Blackboard.
Okay, I found the thing now. It's one rev equals 2 pi radian. So you would use that, right?
That's
To
correct.
convert. Okay.
Just hold on. So for kids, if you go to the course on the syllabus and course materials, which is the fourth link, sorry, the 1, 2, 3, 4, 5, the fifth link in the course menu. If you click on this, takes you here. And 1, 2, 3, 4, the fourth link is a link to download the PDF version of the textbook. Okay, if you haven't yet done so, that's not a good sign. It's not late. You need to download this and have a physical PDF copy of this book on your electronic devices, so that even when you're not connected to the internet, you can still access the course content. Now, this is different from the web version, because in each module, going to each module, under the reading section, you have links to the web version of the textbook. This version doesn't give you access to the end of chapter problems. It does give you all the contents, but you don't have access to the end of chapter problems here. So take note of that key difference. To get access to the version I'm showing on the screen, you need to download the actual copy from the download link in Blackboard. You can also download it here. If you go right up here to the top, get this book. There's this green button that says, get this book. If you click here, it gives you the option to download the PDF of the book. So you can download it here or download directly from the link in Blackboard. So back to the problem. Courtney, go ahead. What did you say was the conversion factor?
It's 1 revolution equals 2 pi radian. And so you would just do 0.1 revolutions times 2 pi radian over 1 revolution.
Okay. So you're definitely right in using this. So basically what you've done is you found the answer. This is part A. You found the answer to part A, and then you're deriving the answer of part B from part A. Now, if your answer in part A is correct, then it's definitely still okay to use that answer in part B. Now, the risk you face with this is that if you made a mistake in part A, then whatever you do in part B will be wrong, because you let's say you incorrectly computed part A and didn't get the right answer, and then you're trying to get the answer for part B from part A, your answer by default will be wrong.
So we should just use the 6.
Yes, to be safe, I would start with what was given, 6 revs per minute. is equal to 6 revs per minute is revolutions over minutes. Then now I begin my conversion factors. I know the two conversion factors are 1 rev equal 2 pi rad, 1 minute equals 60 seconds. So with this, I can then line up the conversion factors, 2 pi rads divided by 1 rev. Remember, my goal is to cancel the rev out, and then the next conversion factor, 1 minute on top, divided by 60 seconds. Again, the goal is to cancel the minutes. And once you simplify, 6 times 2 pi is 12 pi. And then divide by 60 seconds. So you can simplify that. What is 12 pi divided by 60?
Um, 0.6.
0.6. Right.
No, 0.6. I don't, how many, do you just want the one?
Well, if we go back to the problem, how many significant figures were given in the original problem?
1.
Okay, so if it's 1, then we keep 1 significant figure.
Okay.
Okay, so yes, 1 significant figure. And by this same approach, you could also say 6 rev per minute equals 6 rev over minute times, we know 1 minute is 60 seconds. So minutes cancel, and then you end up with the same thing, 0.1 rev per second. So this problem is nothing but a unit conversion problem, even though it deals with rotational motion. You're not really, using the equations or the kinematic equations, rather you're just converting from one unit to another. And you don't need to understand, the details of rotational motion. As long as you have conversion factors, if they ask to convert from one thing to the other, you should be able to do that. So this is really like a chapter 1 problem. Now, number 2. Can somebody read number 2 for us? Number 3, rather.
An automobile with 0.26 meters radius tires travels 80,000 kilometers or kilometers before wearing them out. How many revolutions do the tires make, neglecting any backing up and any changes in radius due to wear?
Okay, so any suggestions on how to approach this?
Would we use one of the formulas for the revolution and radians like together? Would we use one of those? Since
Okay.
we have well, we don't have that, I don't think so. Because we don't have, all we have is the radius and how far it went.
Okay, so again, I deliberately chose this problem because you have to think. Okay, it's not, there's some problems where you just have to, pick or just plug in the numbers into a known equation and solve. But the sum that you have to apply the knowledge of what you've learned from, like, let's say Math 107, which is the language of science, So you need to apply your knowledge of algebra, trigonometry, geometry, and then integrate it with your knowledge of physics. So let's look at this problem. So the radius is 0.26 meters. It travels 80,000 kilometers. And the question is, how many revolutions do the tires make? So we have keywords here. We have radius. So this is the tire.
Excuse me, Dr. Tom.
Yes.
Would you use the rotation angle formula?
What is the rotation angle formula?
Would it be delta, is that sigma? Yeah, delta sigma equals delta S over R.
Delta theta equals delta S over R. Okay.
Yeah.
So, okay. So what you said, delta theta equals
Equals delta S over R.
over R. Okay. So that means delta S equals to what?
Delta S will be your arc length, I think.
Okay. So delta S will be R times the rotational angle, right?
Yes.
Okay. So essentially what we're saying here is, if this is your tire, so if the tire rotates through an arc length of delta S, and the angle is delta theta, of course the radius is R, so this arc length is equal to the radius times the rotational angle. So what is one revolution?
Two radians, but also 360 degrees.
Okay, so this is 2 pi radians, right?
Mhm.
So this means for one revolution, delta S, that is the linear distance, the actual distance around one revolution, is equal to the radius times 2 pi radians, which is, do you recognize this formula? Does anyone recognize the formula 2 pi r? What does it stand for?
Is that circumference?
That's the circumference of a circle, but that's the distance around the circle, right? Does everyone agree, or does anyone disagree?
Yes.
Yeah,
Okay, so what this means is, if you rotate a circle all the way around, the distance it will cover on the ground is equal to 2 pi times r. Okay, so this is the distance corresponding to for one revolution. Now, if we know that the total distance covered is 80,000 kilometers, to find the number of revolutions, we just have to take the total distance and then divide it by the distance covered in one revolution. Does that make sense?
can you say that?
So one revolution, that means the tire rotates once. The linear distance is the circumference, which is 2 pi times r. And since we know the radius here, this is 2 pi times 0.26. And what is that? Let's work this out first.
1.63.
Did you multiply by pi?
Yes.
Okay, 1. Can any other person confirm? because we're going to use this number for the second part.
It's confirmed.
Okay, so 1.63 meters. Now, this is the distance covered once the tire rotates around one complete cycle. Okay, so let's say the tire rotates n times. The distance will be what?
80,000 kilometers.
Well, we know it's 80,000 kilometers, but let's keep that aside. We know that for one revolution, the distance covered is 1.63. If the tire rotated, let's say 10 times, what would be the distance?
16.3.
10 times the distance for one revolution, right?
Mhm.
But one revolution is 1.63. If it rotates 10 times, then 10 times the distance. If it rotates n times, then the distance will be n times 1.63. Okay, and so what this problem is saying, the unknown number n multiplied by 1.63 gives us 80,000 kilometers. And they're asking us to find this n, how many times it must rotate to give us 80,000 kilometers. So the number of rotations or revolution is just 80,000 kilometers divided by the distance for one revolution. Now, does anyone see any problem with this?
Yeah, would we not have to make either meters, kilometers, or kilometers, meters?
Exactly. You cannot divide kilometers by meters. Okay, it's like dividing two different, units. So this will be 80,000 times 10 to the 3, because kilo means 10 to the 3 meters, and then divided by 1.63 meters. Somebody simplify that. Everyone should be doing the computation, so to ensure that we're getting the same answers.
I got a really big number, so I'm not sure if it's right.
What is a big number?
Like 490, I think 1,790, or hang on, 49,079,754.6.
Okay, so
That's
we're
really
going
big
to reduce that to like one significant figure. Okay, so that will be 5 times 10 to the or rotations. Okay, now why we doing that is because if you look at 80,000, so whenever there's no decimal place in a number, sometimes the trailing zeros are not significant, they're just placeholders. So this is technically like one significant digit, and then the 1.63 has 3 significant digits. So your answer will have 1 significant digit, which is like 4.9, right? Is it 4.7? What was the number after 4?
Yeah, 4 and 9, not 4 and 7.
Okay, so 4.9, you round that to 5, to 1 significant digit. So 5 times 10 to the 7 rotations. So again, follow the logic here. We started by establishing the linear relationship between the linear distance and the rotational angle. So the linear distance, delta S, is the radius times the rotational angle. For one complete rotation, the rotational angle is 2 pi radians. So multiply 2 pi radians by the radius, 2 pi r, gives you the linear distance for one rotation, which happens to be the circumference. So what this means, you can visualize it this way. If you took a thread and put it around the tire, then stretch it out, that linear distance is what we're calling delta S, and it will just be equal to the circumference, which is 2 pi r. So the question is asking us, how many of such threads do we need to join end to end to get 80,000 kilometers? And the answer is to take 80,000 and divide by the length of one thread or one rotation. That will give you how many threads or how many rotations you must make to achieve that distance. Number 4. Can somebody read number 4?
I'll read it.
Okay.
It says, what is the period of rotation of Earth in seconds? What is the angular velocity of Earth? Given that Earth has a radius of 6.4 times 10 to the 6 meters at its equator, what is the linear velocity at Earth's surface?
Okay. Any suggestions of where to begin?
I always draw it out first.
Okay, so tell me what to draw.
A circle,
Okay, so I'll draw a circle.
and then put your radius line.
Okay, just give me a second. Let me try to draw a circle. Okay, radius line.
And then you can make it like into a triangle, and then you'll have your angle in the
Okay.
middle, and then your delta S for the outside of it.
Okay, so it's the delta theta and delta S. Okay. So where do we go from here?
Your radius equals 6.4 times 10 to the 6 meters. So I'd write that.
So radius equals 6.4 times 10 to the 6 meters. I've written it down. Again, this discussion is open to the whole class. Don't just be a spectator. If you're not understanding any step, please indicate. If you have any questions, ask. Don't just hope that these things will become obvious to you on the test. If you want to make a mistake, now is the best time to make the mistake because there's a chance to be corrected.
So part A is asking the period of a rotation. Would that just be kind of the same that we did for the last problem for like the first half of it? To get the period of rotation, or no?
What did we do?
Where we did the delta S equals R or equals 2 pi R.
2 pi r, that's the circumference, that's distance. What is period? What does period refer to? What does the word period refer to? Is it a distance? Is it which quantity in physics does the word period refer to?
Is it the time?
The time.
It's a time. So obviously it cannot be 2 pi r because 2 pi r is the circumference. Okay. Now Reed says, isn't rotation 24 hours? And that's correct. So the period for the Earth's rotation is 24 hours. That's what we call 1 day. So 1 day is the time it takes the Earth to complete one rotation around its axis. Okay. And so it didn't say what is the period. Yeah, so it says what's the period of the rotation of the Earth in seconds. So it does specify. So and the symbol for period is T, uppercase T. So 24 hours, which is 24 hours times 1 hour is equal to 60 minutes. And 1 minute is equal to 60 seconds. So simplify this and you get 86,400 seconds. So that's the period of the Earth's rotation. So this is something you knew, but it just didn't occur to you that you could apply it here. So you have to, again, you have to that's why it's important to attempt different problems, because in attempting multiple problems, you come across the different types of problems you would encounter. Now, part B says, what is the angular velocity of the Earth? How do we calculate angular velocity?
I don't know what the W is called, but W, and then you do
The W is called theta.
okay.
No, that's omega. Huh?
Oh.
This is theta. And this is omega.
Oh.
And this is alpha. So you may want to write this down, because you'll be saying this throughout all chapters that deal with rotational motion. And you have to use the right symbol. Okay, you cannot make them up, because each symbol means something else. So omega equals what?
Delta theta
Divided by
delta T.
Okay. So for one, it asks for the angular rotation. So for one rotation, we know the time. Do we know the distance for one rotation, the angular distance for one rotation?
No.
Yes, we do.
Where is it at?
How many rotations does the Earth
Isn't
complete
it,
in one day?
Isn't it 2? Never mind.
2 what? You're on the right path. And that's again the problem of
2 pi radians or something like
pi
that.
radians. So right here, let's go back here. 1 revolution is equal to 2 pi radians, right?
Which is oh, never mind.
Remember, we're not talking about the linear distance. We're talking about the angular distance. That's 2 pi radians, right? Because they're not asking for the linear speed, they're asking for the angular velocity, which is the angular displacement, 2 pi radians for 1 revolution. And 1 revolution is completed in 24 hours, which we just calculated to be 86,400 seconds. So this is 2 pi radians divided by 86,400 seconds. Okay, and if you work this out, you should get 7.3 times 10 to the 5 minus 5 radians per second. Please confirm if you got that.
Yeah, that's what I got.
Okay, 7.3 times 10 to the minus 5. Okay. And part C says, given that the Earth's radius is 6.4 times 10 to the 6 meters at equator, what is the linear velocity? So R equals 6.4 times 10 to the 6 meters. What is the linear velocity? Does anyone remember the equation? The relationship between linear velocity and angular velocity?
Is it, would it just be R delta theta over delta T or no?
Well, what is delta theta over delta T?
Just R times what we got for on the last slide?
R times omega. We have this equation, right? In chapter, remember you have the equation list, the list of equations for the whole course. So you can also use that formula sheet during this session or during your study session, because that's when you practice, identifying the right equations, because you will have access to those equations on the test. So the linear velocity is just R times omega, and that is 6.4 times 10 to the 6 times 7.3 times 10 to the minus 5 rad per second, and this gives you what do you get when you multiply this? Anyone?
It's 467.2.
So
So it'd be 4.7 times 10 to the 2.
yes, 4.7 times 10 to the 2 meters per second. Or 470, because again, the trailing zeros most of the times are considered not significant. So 47 will be 4 and 7 will be 2 significant digits. Okay. Any questions? Okay. So I've shown you what to do. This is what you're supposed to do after reviewing the recorded lecture and the practice problems in each module. You need to go to the end of chapter problems and attempt as many as possible. and note the ones you don't know how to solve, or the ones you can only do part, and then bring this up during the tutorial session. During the tutorial session, I'm really expecting students to come and show me what they attempted and where they got stuck, and then I'll show you how to get past, the roadblock, and that's how you develop confidence in, solving problems on your own. If all you've done is review the solutions that were given to you in class, I can confidently tell you here that you're not preparing the right way, and you'll be surprised that during the exam, everything will look strange to you. So if you've not started doing the practice problems, know that you're not taking the right approach. And in chapter 5, under the lectures folder, let me show you. Let's go back to here. So under the lectures folder, just below the recorded lecture, there is a number of recorded problems and solutions. So review this as a starting point. And then use this as a guide to attempt, similar problems from the end of the chapter. Okay, so take advantage of this, and on the test is next Tuesday, so that means our next meeting on Tuesday will be the test. But on Thursday, I'll be having, a review session at 2 p.m. with the Thursday class, and you're welcome, you're welcome to attend that session if you're available. But the recording will be made available in Blackboard. But between now and Tuesday, for this section, your evening tutorial session is on Wednesday, which is tomorrow at 7 p.m. If you haven't signed up and you have questions from chapters 3, 4, 5, you need to sign up and take advantage of those evening tutorial sessions tomorrow. So I'm going to take attendance now before dismissing the class. But if you have